Before we get to our next sack, we have this thing to learn, which is using matrices to map transformations onto our graphs. Okay, so we won't just be doing it by looking at the equation or just by understanding the translations, dilations, and reflections just from the algebra that's involved. We're actually going to have to use matrices to show how a function can be transformed into another function. So before we do that, we obviously don't assume that anybody knows anything about matrices because they're not taught before year 11. So we have a little introductory, pretty basic lesson on what a matrix is and how you add them and how you multiply them. Because 2/3 of you guys have done general maths already, you'll know this stuff, so you should fly through this chapter. But it would be pretty rude of us to just jump into transformations through matrices when some of you don't actually know what a matrix is. So let's have a look. If you've never seen a matrix before in your life and you're wondering what a matrix actually is, want to know more, just look at the screen. Here it is. A matrix is an array of numbers, or almost like a grid of numbers. It just is a way of organizing numbers into rows and columns so we can perform mathematical or numerical calculations with combinations of numbers all at once. It lets us group our numbers together in a grid and then apply those numbers to other groups of numbers. So we've just got to know the features of a matrix. So this is a matrix that has 2 rows and 3 columns. Okay, we can see we've got 2 different rows going across, right? 1 and 2, and then the columns we can read that way: 1, 2, and 3. And just as we go through, if we're talking about the singular, we'll have one matrix, or the plural of that is matrices. All right, so let's have a closer look at them. One of the most important features of a matrix, and if you guys ever do further maths, you'll soon figure this out, is that order is very, very important, no matter what kind of maths you're doing with matrices. The order of a matrix is just its size and its shape, because certain maths can be done when matrices are the right shape, and if they're the wrong shape, then you can't do any maths at all with them. So when we talk about the order or the shape of a matrix, we give rows first, then columns. So this one has 4 rows going across and 3 going down. So this is a 4 by 3. All right, this doesn't mean 4 times 3. We're not just going to write down it equals 12 as an answer. 4 by 3 means 4 rows and 3 columns. If you times them together to get 12, that will give you how many numbers are in it, but just leave it as 4 by 3. Don't write 12 underneath. And this one is a 3 by 4. Right, we've got 3 rows going across, 4 columns going down. That is the order of those matrices, always rows before columns. The next thing you know is that matrices are full of elements. The elements are just usually the numbers or maybe the variables if we've got letters involved that make up our matrix. We can talk about particular elements of a matrix by using shorthand. We usually write down the row and the column number in that order that they are. So if I'm talking about the element 1, 1 of this matrix here, well, 1, 1 means in the first row, so in the top row, and in the first column going side to side. So 1, 1 is talking about the letter A. 1, 2 would then talk about the top row, the first row, second column in, that would be C. And following on from that, 2, 1 would be B, second row down, first column in, and 2, 2 in this case is D. All right, this just helps us find elements in a matrix. By the standard of question we've been answering in class, these ones shouldn't trouble you too much today. We're just getting to know these matrices. You'll answer questions like this. What is the order of matrix A? Matrices are generally represented with capital letters, just by the way, especially when you do further maths. So the order of A, how many rows, how many columns? It is a 3 by 2. Right, 3 rows going across, 2 columns going down. Find element 2, 1. So we're looking second row down, first column in. So that element would be the 3 in this matrix. And which element is the number 6? You can see the 6 is in the third row down and the first column in. All right, that should get you on your way. So once you've got that basic understanding of what a matrix is, and it's got an order which tells us its size and there are elements inside it, we can start to actually maths with it. So the main things you'd be doing today, you'll be adding, subtracting, and multiplying matrices together, just to make sure you understand how that works. So when we get to our transformations, you'll see the way the matrices are all lined up, and you'll understand what's being added together and what's being multiplied. So with adding, basically, we just have to add the numbers that are in the same spot from one matrix to the other. So what that means is if I want to actually add two matrices together, they have to be the same size, or they need to have the same order. You have to have the same amount of rows and the same amount of columns. Otherwise, you won't have matching things in matching spots to add together. So basic example of that is right in front of you. We've got 3 plus 4 equals 7, and you have to write your answer where the elements were that you added, all right? So since I added element 1, 1 in each matrix, the answer goes in element 1, 1, right? 3 plus 4 is 7, 8 plus 0 is 8, 4 plus 1 is 5, and we can have negatives as well. 6 plus negative 9 makes negative 3, all right? So adding's pretty straightforward, just add the things in the same spot. It's also worth mentioning that subtraction is the same. Plussing and minusing generally work the same way. So you can subtract two matrices as long as they're the same size, because you just take away the elements that are in the same spot as each other. With multiplication, first of all, multiplying by a constant or just multiplying a matrix by a number is really easy. If there's a 2 in front of a matrix, times everything by 2. All right, so to turn this into that, you can see everything's been doubled. We can call that multiplication by a constant, or you might more commonly see it referred to as scalar multiplication. So putting these ideas together shouldn't trouble you guys too much. If you get asked to do something like this, where I've got 5 lots of m, take away 2 lots of n, following BODMAS, like always, we've just got to do the multiplication before we subtract. So what you'd be asked to do is just multiply everything in this first matrix by 5 and everything in this one by 2, and then subtract them from each other. So we'll try and do this as fast as we can. All right, so it'll be negative 10 there, 20 here, 0 there, 15 there, 30 here, minus 45 here, 25 here. Good practice for our 5 times tables, I guess, when we do non-calculator sacks. And 2.5. We've got a subtraction in between, and we've been asked to double matrix n. So we'll chuck an 8, negative 6, 4, 2, 12, 0, minus 14, and 16 into that one. And then, of course, we're allowed to subtract these from each other because they are the same size and shape. They've got the same order. They are both 4 by 2 matrices. So we'll go negative 10, take away 8. 20, take negative 6. We get to practice taking a negative, which is plussing. 0, take 4 is negative 4. 15, take 2 is 13. 30, take 12 is 18. Minus 45, take away 0. 25, take minus 14, and 2.5, take away 16. All right, so we can now multiply by a constant or a scalar, and we can subtract as well, all in one go. Hooray for us. All right, so where it gets marginally more difficult for us is when we're asked to multiply a matrix by another one, which is something that's going to be part of our work when we do our transformations with our matrices next class. So we're not just timesing a matrix by a whole number anymore. That's pretty straightforward. We're going to be having a matrix next to another matrix. We'll times them both together, and we'll soon figure out how that works and when we can and can't do it. Because what we've got here, as you can see, we've got matrix A and matrix B. We're being asked to times them together. Matrix A is a 1 by 3. Matrix B is a 3 by 2. And the answer that comes out the other end ends up being a 1 by 2. So you can see there is a rule to it, there's a pattern to it, there's a fair bit of working out going on with these combinations of numbers. They work in a particular way. So we'll give you the rules for how it works, how you can do it, and what kind of answer you should be looking for. So if all that working out on the previous slide looked a little bit like convoluted and messed up, don't worry, it is a little bit, but this is just the way matrices work and kind of why they exist. It's so we can kind of have some rows in our first matrix and some columns in our second matrix that need to go together, so you can do things like figure out how much money you make from your pies when you sell different types of pies on different days. So it really is just a good way of organizing numbers and timesing together particular combinations of them when you need to do multiple calculations all at once. So when we do this multiplication, these are the rules you have to follow. Okay, so some of the questions today will just ask, can you actually multiply these two matrices or not? Is the answer going to be defined? Does it exist or doesn't it? So what we have to just check is that the columns in the first matrix equal the rows of the second matrix. So a really good thing to do when you get a multiplication question is just write down the order of both matrices. So this is a 2 by 3, and this is a 3 by 2. Okay, so when we talk about the columns of the first matrix, remember that when we write down the order of a matrix, we go rows and then columns. So we're comparing the columns of the first matrix with the rows of the second matrix. Okay, rows and columns, rows and columns. We're basically comparing the two numbers in the middle if you write it out like this. And that's why it's good to write it out like that, because then you can just look in the middle and ask yourself, are these two numbers the same? And because these two numbers match, I've got 3 columns here, 3 rows there. I am allowed to multiply, and then the result, the matrix that comes out the other end when I actually do it, will have the same number of rows as the first matrix and the same number of columns as the second matrix. Okay, so these inside values tell me whether I can multiply, and the outside values tell me what kind of answer to expect. And I can then set up a matrix that will allow for that answer. Okay, the answer is going to be a 2 by 2, so I can set myself up a 2 by 2 and get ready to do some working out. And we'll do that working out in a minute. That was a pretty quick minute. Let's get into it. So we established in the previous slide that we were looking for an answer that's going to be a 2 by 2 matrix. So let's look at how it's done. So when we're multiplying, one of the reasons why we needed some columns and rows to match is that we're going to be working with the rows of the first matrix. So we're going across where it goes 1, 2, 3, and we're going to be working with the columns of the second matrix. So each row has to multiply each column. So we're going to start with the top row, and we're going to start with the first column. And what we do is we work with the first number in each of those things. So we have to multiply the 1 by the 7. Okay, and we've got to keep working our way across through the row and down through the column until we've used up all the numbers in it. Okay, so the next thing we're going to do is we're going to move across here to the 2 and down to the 9. We're going to go 2 times 9, and we're going to be going 3 times 11. Okay, moving across and moving down. And what we do with all these sums that we've put together is we're going to add them. Okay, and what this makes is one total number that goes into my answer matrix. So this is 7, this is 18, and this is 33. So our first number in our answer matrix is 58. Okay, now we have to multiply each row by each column. So generally, the best advice you can follow is just start with the top row and then do it with every column until you've run out of columns to multiply. So I'm going to continue using this top row, but I'm now going to multiply it by this column here. So again, start with the first numbers in each row or column. 1 times 8. Then I'm going to be adding 2 times 10. And I'm going to be adding 3 times 12. And these 3 things multiplied and added will give me my next answer. Okay, so this is 8, 20, and 36. So that's going to be 64. And then the question is, where do I put it? Because I'm using the top row and the second column, my answer should go in the top row and in the second column. Okay, just use the location of the things you're multiplying to put your answer in the right spot. Okay, now there are no more columns for me to multiply this top row by, so I'm going to move on to the bottom row. Okay, so the bottom row is now going to multiply each of these columns as well. All right, so let's work our way through. We've got 4 by 7. We've got 5 by 9. And we've got 6 by 11. I think that's 139. I'm not sure. It'll do. Remember, because I used the bottom row and the first column, I put my answer in the bottom row and in the first column. And the last thing we need to do now, we haven't multiplied this bottom row by this second column, so we need to do that as well. 4 by 8, 5 by 10, 6 by 12, 154. Okay, and that is how you manually multiply two matrices together. And of course, why would you do that when you've got a graphics calculator? So your bookwork is going to throw a whole bunch of just matrices at you and ask whether you can actually multiply them together or not. And then you only really have to do the ones that exist, because if it doesn't exist, how can you do it? So here are 5 matrices, A, B, C, D, E. They want us to find, where possible, A times B, B times A. And what we'll soon figure out is that matrices don't work like numbers. If you change the order that they're multiplied in, you'll get a completely different answer, or maybe you won't get an answer at all. AD, AE, and CE. So for a start, we'll just see which ones exist. So you should always just be checking the orders of them. So this one is a 2 by 3. This one is a 2 by 2. And because the numbers in the middle are not the same as each other, this one is undefined. It does not exist. Okay, but just because I couldn't multiply A times B doesn't mean I couldn't do B times A. Okay, so we need to do the same thing and check the orders again. Because we flipped them around, we might have something nicer waiting for us. So this is a 2 by 2 and this is still a 2 by 3. And what you'll see now is that the two numbers that are in the middle, they do match, which means in theory there is an answer. And that answer would have 2 rows and 3 columns. If you wanted to go through and do that multiplication, you would start with the top row and you'd multiply it by each of these columns. First of all, by that one, and that one. They would give you the answers that go in here. And then you could do the same thing on the bottom as well. You'd use this row and multiply it by that one, and that one. And you'd get the 3 answers in the bottom. We'll leave it for now. If you want to double check the working out, go back and watch the last one again. So let's check this one out. CE, can I do it? This one is a 3 by 2. This one is a 2 by 1. So in theory, I can do that one. And the answer would end up being a 3 by 1. Right, we've got to go this one by that. And then we'll have to go this row by that column. Right, there's only one column for each row to multiply. Okay, so the green parts I circled in green will put an answer that goes here. The ones I circled in red would go there. And then you'd multiply the bottom row by that column and it would give you an answer that goes here. Okay, so we could actually do that one if we wanted to. And we did skip to E because C and D, they're both undefined as well, right? We've got a 2 by 3 and a 1 by 2, right? These numbers in the middle are no good, so I can't multiply them together. And same goes for this one as well. So out of these 5 options, I couldn't do A, I couldn't do C, and I couldn't do D. So in your workbook, you only have to multiply the matrices together that are actually defined and exist.